Alright, for this video, we're going to be talking about solving exponential equations with logarithms. Now, we bring this up because we can solve these type of equations pretty relatively easily. So 3 to the x equals 81, we want to solve for x. So we just got to think of 3 to what power equals 81. Well, if we understand our exponential tables, which can be difficult sometimes, we know that 3 to the 4th equals 81. So we need 3x equals 3 to the 4th. So that means x must equal 4. Same idea for the one to the right here. We have 5 to the 7 minus x equals 125. 125 is the same thing as saying 5 to the third power. So we have 5 to the third equals 5 to the 7 minus x. Now we have the same base, we just set the exponents equal. Okay, now it's just a coincidence that they both have to be 4. But, so this is relatively easy problems to deal with solving exponentials. In the next slide I'll show you ones that are more difficult. Alright, this is where solving exponential equations is going to get a little tricky. Here we have 5 to the 3x equals 16. Well, in the last couple of problems we thought to ourselves, well, 5 to what power would equal 16? Well, 5 to no whole number is going to give us 16. 5 to the second is 25, 5 to the first is 5, so we need to use some logarithms. And we're going to use the properties of logarithms. That's going to give us our answer. So we can do it two ways. Our first way is going to be rewriting the logarithm, or rewriting the exponential as a logarithm. So for 5 to the 3x equals 16, that gives us log base 5 of 16 equals 3x. How do we evaluate log base 5 of 16? Well, for that, we're going to use the change of base formula. Remember back in the change of base formula, it says if we have a log base 5 of 16, we can rewrite that as log 16 or log of 5. Remember, if there's no base written, it's base 10. So these are both base 10, which is something we can plug in the calculator. And that equals 3x. And now we just got to solve for x. So that means we divide both sides by 3. So we have log 16 divided by log of 5. All that divided by 3. So that's the exact answer. But if we wanted to approximate, we would type it in the calculator. We would just do log of 16, close your parentheses, divided by log of 5, close your parentheses, then divide by 3. And you should get approximately 0.5742. I usually go to 4 decimal spots just because that's a good number. So that is our answer for method 1. Method 2 is going to be using our log properties more effectively. So what we're going to do is we're going to take the natural log of both sides of our exponential. So here we have our original problem, and I'm going to take the natural log of both sides. And that's allowed because I did the same exact thing to both sides of the equation, so nothing really changed. Now, why did that help? So we have natural log of 5 raised to the 3x. Well, thinking back to the properties of logarithms, we know that if we have a logarithm being raised to an exponent, we can bring that exponent out front. So that's what I'm going to do. So we have natural log of 5 to the 3x. So I'm going to bring down that 3x to both sides. Well, just that at front, I mean. Okay. Now, I want to solve for x, so I'm going to divide both sides by the natural log of 5. And then divide both sides by 3. Okay. Now, that's our exact answer. That is our exact answer. So let's get it approximately. because that's what the question is asking for. So I'm going to do natural log of 16, close parentheses, divided by the natural log of 5, close parentheses, divided by the natural log of 3. Whoops, not natural log of 3, just 3. And we're going to get 0.5742. Okay, now both of these methods are correct, just a little bit different. Now, I'm sure you're wondering, why did we use natural log? Why didn't we just use a regular log? Well, you could have. You could have just taken the log of both sides if you wanted to. I just chose to use natural log, one, because it's not as much writing, and two, I just wanted to show that you can use both of them. So the reason we used the natural log is because the natural log is available on the calculator. You can plug in natural log. You can plug in log into the calculator. Okay, so that's the whole purpose. So we're going to be able to solve for x using these natural logarithms. Alright, we have one more example. It's a little bit more complicated. It's 4e to the x squared plus 3 equals 19. So I want to solve this exponential equation. And it's an exponential because we have a variable inside of the exponent. So the first thing we want to do is I want to isolate the exponential. So that means get it by itself. So I'm going to subtract 3 to both sides. And I'm going to get that 4 out of the way, so I'm going to divide both sides by 4. Alright, now we have the exponential all by itself. We have e to the x squared equals 4. Now I'm going to solve that using one of the methods we discussed before. Just for argument's sake, I'm going to use the second method. So I'm going to take the natural log of both sides. And I'm going to bring, since we have the natural log of a log being raised by an exponent, I'm going to bring that x squared out front. Okay, now we have x squared times the natural log of e equals the natural log of 4. The natural log of e, if we remember correctly, natural log is the same thing as log base e. So here we have the natural log of e. So this is saying e to what exponent is e? Well, natural log of e is going to be equal to 1. So we have x squared times 1 equals natural log of 4. So now I want to get x by itself, so I'm going to take the square root of both sides. So we have x equals the square root of natural log of 4. And remember, if you take an even root, you need to do the plus minus. Okay, and that's our exact answer. So now I'm just going to give the approximate. So we got the square root of the natural log of 4. Again, this is all stuff you plug into your calculator. And that gives us approximately plus minus 1.1774. Okay, now I just solved a bunch of exponentials using logarithms. Good stuff. Alright, after watching that video, you should feel comfortable doing a couple problems. This is on page 392. And I'm going to have you do numbers 15, 17, 19, 18. So numbers 15, 17, 18, and 19. Okay, so give those a try. Come to class with questions, of course, and we'll get this done.